Good day again to everyone, special to my listeners and viewers. So welcome to my channel. So for today's video, we are going to discuss the topic in Calculus 2, and this is the integration rules. So I think integration rules is not familiar from you, and other one is familiar from them. So by the way, integration is can be used to find volumes, central points, and many useful things. So it is often used to find the area underneath the graph of a function and the x-axis. So the first rule to know is that integrals and derivatives are opposite. So remember, the integral and derivative here is opposite. So always remember, with the integral and derivative are opposites. So have you seen the graph here from the other side or from your right hand? So now the integration rules. So I have here the table which represents the common functions, the function and the integral. So from the common function, we have the constant, variable, square, reciprocal, exponential, and trigonometry, in which the x in radians. So with the corresponding functions, we have the constant, which is the integral a dx, as well as the integral corresponding is ex plus c. However, the variable is the integral x dx, and the integral here, or the corresponding integral for the variable of common function, is x squared over 2 plus c, as well as the square, reciprocals, exponential, and so on. If you are interested with this topic, you can analyze the integration rules with the corresponding common functions, the function, and integral to the table. So we have here also the table in which the rules, the function, and the integral. So we have the multiplication by constant, in which the function here is the integral cf of x times dx, and the integral here is the c integral of f of x dx. So they are, if you can see the table, the function integral, it shows there are similarities, but it should be different. So second one is the power rule, in which the n is not equal to -1. So the function is the integral x to the power of n dx. So by their corresponding integral, it will be the x to the power of n plus 1 over n plus 1 plus c. However, the sum rule, the difference rule, the integration by parts. So you have the time to connect with the function and the integral. So you can follow the table only. Now we have the examples for you to understand well with this topic. So for the example, we have what is the integral of sine x. So from the table above, it is listed as being negative cos x plus c. It is written as integral sine x dx is equal to negative cos x plus c. So as we see the table here, the sine x dx, sine x dx. So the sine x dx is correspond with the, so here sine dx is correspond with the integral, in which this the cos, negative cos. You can see the table here. Next, we have the example number 2, which is what is the integral of 1 over x. So from the table above, or from the table I represent earlier, it is listed as being n times x plus C. So it is written as the integral of 1 over x dx is equal to n is equal to nx plus c. So we can see the table here, 1x dx. So here, it is the reciprocal, which is the common function is the reciprocal. So the function here is this. Then the integral corresponding is the nx plus c. So that's it. So I hope you will understand of what we are tackled with this video. So thank you, and if you are new with this, or if you are new in my channel, don't forget to like, share, and subscribe, and don't forget to hit the notification bell below for you to watch my next upcoming video. Thank you, and God bless everyone.